there are 3 resonance of chlorate ions are given, and I will discuss how to assign the formal charge or a particular atom in these ions. The formula for formal charge is given here. The number of valence electrons shown by an atom minus bracket 2 multiplied by number of lone pairs plus number of chemical bonds formed by the atom in the ions or compounds. Well, let me start with first chlorate ions, and so we calculate the formal charge over this oxygen atom. Well, let me write here oxygen atom, and so we apply the formula. It says number of valence electrons. Oxygen has 6 valence electrons minus, and the formula says 2 multiplied by number of lone pairs. Lone pairs electrons are the pair of electrons which do not take part in bond formation. Well, oxygen has 3 lone pairs, 1, 2, 3. It has 3 lone pairs, I mentioned here 3, plus number of chemical bonds. Oxygen forms only 1 chemical bond, I mentioned here 1. Now we can do the calculation. 6 minus 2 3 is 6 plus 1, and say here we have 6 minus 6 plus 1 is equal to 7. Here we get minus 1. Well, the formal charge over this oxygen atom is minus 1. Well, remember, atoms with the same number of lone pairs and same number of chemical bonds share same formal charge. If you compare these 3 oxygen atoms, each oxygen atom has 3 lone pairs, and same number of chemical bonds. Each oxygen atom is forming 1 chemical bond. That's why each oxygen atom is sharing minus 1 formal charge. Well, now we calculate the formal charge over chlorine atom. We apply in the same formula. Well, formula is number of valence electrons. Chlorine is a halogen atom, and halogens are present in 7th group in the periodic table, and the number of groups represents the valence electrons present in the halogens. Well, halogen have 7 valence electrons, and minus formula is 2 multiplied by number of lone pairs. Well, chlorine atom has 1 lone pair. Here I mentioned here 1, plus number of chemical bonds formed by chlorine atom 1, 2, 3. It forms 3 chemical bonds. I mentioned here 3. Now we can do the calculation. 7 minus 2 1 is 2. Here we have plus 3. Well, 7 minus 2 plus 3 is equal to 5. Here we get plus 2. Well, the formal charge over this chlorine atom in this chlorate ion is plus 2. Let's move on to the next resonance of chlorate ions, and we calculate the formal charge over this oxygen atom. Well, if you compare this oxygen atom with this oxygen atom, both oxygen atoms are having the same number of lone pairs. Each oxygen atom has 3 lone pairs and forming 1 chemical bond. That's why it will also share minus 1 formal charge. Now we calculate the formal charge over this oxygen atom. We apply the formula. Well, the number of valence electrons, oxygen obviously has 6 valence electrons, minus the formula is 2 multiplied by number of lone pairs. This oxygen atom has 2 lone pairs, I mentioned here 2, plus number of chemical bonds. This oxygen atom is forming 2 chemical bonds, I mentioned here 2. Now we do the calculation. 6 minus 2 2 is 4. Here we have, sorry, it is 4, and here we have 2, and say here we get 6 minus 4 plus 2 is equal to 6. 6 minus 6 will get cancelled, we get 0. Well, the formal charge over this oxygen atom is 0. Well, now we calculate the formal charge over this oxygen atom. Here we have oxygen, number of valence electrons, it has 6, minus bracket 2 multiplied by number of lone pairs. This oxygen atom has 2 lone pairs, I mentioned here 2, plus number of chemical bonds. This oxygen atom is forming only 1 chemical bond. We mentioned here 1. Now we do the calculation. 6 minus 2 2 is 4, and here we have plus 1. Well, we get 6 minus 4 plus 1 is equal to 5. Here we get plus 1. Well, the formal charge over this oxygen atom is plus 1. Now let's move on to the last resonance of chlorate ions, and so we calculate the formal charge over this oxygen atom. Well, if you compare this oxygen atom with this oxygen atoms, you can see that both oxygen atoms are having same number of lone pairs, and they are forming same number of chemical bonds. That's why this oxygen will atom will also share same formal charge as does this oxygen atom, and similarly this oxygen atom will also have 0 formal charge, and so this oxygen atom will also have 0 formal charge, because each oxygen atom is having same number of lone pairs and same number of chemical bonds formed. Now we calculate the formal charge over this chlorine atom. Chlorine is a halogen atom and it has a 7 valence electron, and so 7 minus 2 multiplied by number of lone pairs. This chlorine atom has only one lone pair, I mentioned here 1, plus number of chemical bonds formed by this chlorine atom 1, 2, 3, 4, 5, 6. It forms 6 chemical bonds. Now we do the calculation. 7 minus 2 1 2, and here we have plus 6. Here we get 7 minus 2 plus 6 is equal to 8. Here we have minus 1. Well, the formal charge over this chlorine atom is minus 1. Well, let me take another examples. There are 3 resonance of cyanate ions are given here, and we calculate the formal charge over this nitrogen atom using the same formal charge formula. Well, let me write down here nitrogen atom, and the formula is number of valence electrons. Nitrogen has 5 valence electrons, and so minus, and the formula is 2 multiplied by number of lone pairs. Here we have 2 multiplied by number of lone pairs. And nitrogen has 2 lone pairs. We mention here 2, plus number of chemical bonds formed by nitrogen atom. It forms 1, 2 chemical bonds. Now we can do the calculation here. 5 minus 2 to the 4, and here we have 2, and so 5 minus 4 plus 2 is equal to 6. Here we get minus 1. Well, the formal charge over this nitrogen atom is minus 1. Well, we calculate the formal charge over this carbon atom. We mention here carbon. The number of valence electrons shown by carbon atom is obviously 4, and minus 2 multiplied by number of lone pairs. And carbon atom does not have any lone pair in this cyanate ion. That's why we mention here 0, plus number of number of chemical bonds formed by this carbon atom. It is forming 4 chemical bonds. So 1, 2, 3, 4. I mentioned here 4. Well, we can do the calculation. 4 minus 2 multiplied by 0 is equal to 0. Here we get plus 4. Here we have 4 minus 4, and both will cancel out. We will get 0. Well, the formal charge over this carbon atom is 0. We calculate the formal charge over this oxygen atom. We apply the same formula. Number of valence electrons. Oxygen obviously has a 6 valence electrons, minus, and multiplied by 2 multiplied by number of lone pairs. Here we have 2 multiplied by number of lone pairs. Oxygen atom has a 2 lone pairs. I mentioned here 2, plus number of chemical bonds formed by this oxygen atom. It forms 2 chemical bonds. I mentioned here 2. We do the calculation here. 6 minus 2 to the 4, and here we have plus 2, and here we get 6 minus 4 plus 2 is equal to 6. 6 will cancel out. Here we get 0. Well, the formal charge over this oxygen atom is 0. Well, let's move on to the next resonance of cyanate ions. We calculate the formal charge over this nitrogen atom. We apply the formula. Number of valence electron. Nitrogen has 5 valence electrons, minus 2 multiplied by number of lone pairs. It has only 1 lone pair. I mentioned here 1, plus number of chemical bonds formed by this nitrogen atom. It forms 1, 2, 3 chemical bonds. Well, here we have 5 minus 2 1 2. Here we get 3, and 2 plus 3, and 5 minus 2 plus 3 is equal to 5. 5 will cancel. Here we get 0. Well, the formal charge over this nitrogen atom is 0. Well, if you compare this oxygen atom and this this carbon atom and this carbon atom, so both carbon atoms are forming same number of chemical bonds. It also forms 4 chemical bonds, and it also forms 4 chemical bonds, and both carbon atoms don't have lone pairs. That's why both carbon atoms are sharing same formal charge. We can assign a 0 formal charge over this carbon atom as does this carbon atom have. Well, now we calculate the formal charge over this oxygen atom. We apply the formula. Number of valence electrons. Oxygen obviously has a 6 valence electrons, minus 2 multiplied by number of lone pairs. Oxygen has this oxygen atom has 1, 2, three lone pairs, plus number of chemical bonds formed by this oxygen atom, it forms only one chemical bond. I mention here 1. 6 minus 2, 3 is 6, and here we have plus 1. We can do the calculation further. 6 minus 6 plus 1 is equal to 7. Here we get minus 1. Well, the formal charge over this oxygen atom is minus 1. Let's move on to the last resonance of cyanate ions. We calculate the formal charge over this nitrogen atom. Well, we apply the formula. Nitrogen has 5 valence electrons, and minus 2 multiplied by number of lone pairs. This this nitrogen atom has 3 lone pairs. I mentioned here 3, plus number of chemical bonds. It forms only one chemical bond. Now we do the calculation here. 5 minus 2, 3 is 6, plus 1, and say here we have 5 minus and 6 plus 7. 6 plus 1 is equal to 7, and here we get minus 2. Well, the formal charge over this nitrogen atom is minus 2. Well, if now this carbon atom has a similar same number of chemical bonds as does this carbon atom, and so both carbon atoms don't have lone pairs. That's why this carbon atom also has the same formal charge as does this carbon atom. Well, we calculate the formal charge over this oxygen atom. We apply the formula. The number of valence electrons shown by oxygen atom is obviously 6 minus 2 multiplied by a number of lone pairs. Oxygen atom has only one lone pairs. I mentioned here 1, plus number of chemical bonds formed by this oxygen atom 1, 2, 3. It is forming 3 chemical bonds. Now we can do the calculation. 6 minus 2, 1 is 2. Here we have 3, and 6 minus 2 plus 3 is equal to 5. Here we get plus 1. Well, the formal charge over this oxygen atom is plus 1. Let me take the last example, that is thiocyanate. There are 3 resonances of thiocyanates are given here, and we calculate the formal charge of atoms in these ions using the same formula. Let me start with the first resonance of thiocyanate ions, and we calculate the formal charge over the sulfur atom. I write here sulfur atom and apply the formula. Number of valence electrons. Sulfur is present in oxygen group, and oxygen group is located in 6th A group in the periodic table, and the group number represents the number of valence electrons in the atoms. Sulfur atom has 6 valence electron, and as here we have minus, and the formula says 2 multiplied by number of lone pairs. Sulfur atom has 2 lone pairs. We mention here 2, plus the number of chemical bonds formed by sulfur atom. It forms 2 chemical bonds. We mention here 2. Now we do the calculation. 6 minus 2, 2 is 4. Here we have 2, and 6 minus 4 plus 2 is equal to 6. 6 will cancel here. We get 0. Well, the formal charge over the sulfur atom is 0. We calculate the formal charge over carbon atom. Number of valence electrons. Carbon obviously has 4 valence electrons, minus 2 multiplied by number of lone pairs. This carbon atom does not have any lone pair. We mention here 0, plus the number of chemical bonds formed by carbon atom. It forms 1, 2, 3, 4 chemical bonds. Now we can do the calculation, and say 2 multiplied by 0 is equal to 0. Here we have plus 4, and here we get 4 minus 4, that is equal to 0. Well, the formal charge over this carbon atom is 0. We calculate the formal charge over this nitrogen atom. We apply the same formula. Number of valence electrons. Nitrogen has 5 valence electrons, minus 2 multiplied by number of lone pairs. This nitrogen atom has 2 lone pairs. We can mention here 2, plus the number of chemical bonds formed by this nitrogen atom. This nitrogen atom forms 2 chemical bonds. Now we do the calculation. 5 minus 2, 2 is 4, and plus 2, and here we get 5 minus 4 plus 2 is equal to 6. Here we get minus 1. Well, the formal charge over this nitrogen atom is minus 1. Well, Let's move on to the next resonance of thiocyanate ions, and we calculate the formal charge over the sulfur atom, number of valence electron. Sulfur atom has 6 valence electrons minus, and here we mention 2 multiplied by number of lone pairs. This sulfur atom has only 1 lone pair, and plus the number of chemical bonds formed by the sulfur atom. It forms 3 chemical bonds. I mentioned here 3. Now we do the calculation. 6 minus 2 1 is 2. Here we have 3, and see here you can say 6 2 plus 3 is equal to 5. Here we get plus 1. Well, the formal charge over this sulfur atom is plus 1. Well, if you compare this carbon atom with this carbon atom, so both carbon atoms are forming same number of chemical bonds, and both don't have lone pairs. That's why both are sharing same formal charge. We can assign 0 formal charge for this carbon atom as does this carbon atom have. Well, now we calculate the formal charge over this nitrogen atom, and nitrogen obviously has 5 valence electrons minus 2 multiplied by number of lone pairs. It has 3 lone pairs. We mentioned here 3, and plus number of chemical bonds formed by this nitrogen atom. It forms only 1 chemical bonds. I mentioned here 1. We do the calculation. 5 minus 2 3 is 6, and plus 1. Here we get 5 minus 6 plus 1 is equal to 7. Here we have minus 2. Well, the formal charge over this nitrogen atom is minus 2. Well, let's move on to the last resonance of thiocyanate ions, and we calculate the formal charge over the sulfur atom. We apply the same formula. Sulfur has 6 valence electrons minus, and so it is 2 multiplied by number of lone pairs, and so this sulfur atom has 3 lone pairs. I mentioned here 3, plus number of chemical bonds formed by this sulfur atom. It forms only 1 chemical bonds. Well, 6 minus it is 2. 2 multiplied by 3 is equal to 6. Here we have plus 1. Now we can do the calculation further. 6 plus 1 is equal to 7. Here we get minus 1. Well, the formal charge over this sulfur atom is minus 1. Well, this carbon atom has same number of chemical bonds as does this carbon atom, and so both don't have lone pairs. That's why it will also have same formal charge as does this carbon atom. Now finally we calculate the formal charge over this nitrogen atom. Number of valence electrons shown by nitrogen atom is 5 minus 2 multiplied by number of lone pairs. This nitrogen atom has 1 lone pairs, and plus number of chemical bonds. And nitrogen has 3 chemical bonds. I mentioned here 3. 5 minus 2 1 is 2. Here we have plus 3, and 5 minus 2 plus 3 is equal to 5. Here we get 5 minus 5 is equal to 0. Well, the formal charge over this nitrogen atom is 0. Well, this is how we calculate the formal charge over a particular atom in an ions by using this formula. The first step is to draw the Lewis structure of a compound or polyatomic ion, and once the Lewis structure is drawn, we can apply this formula to calculate the formal charge over a particular atom in a compound or in a polyatomic ion.